What are halogenoalkanes? Halogenoalkanes are any compound that, or alkane type compound, or any alkyl chain, any carbon chain that has a halogen in it. So it could be Cl, Bri, or in rare circumstances, it could also be astatine. So it's alkyl chain or carbon chain plus halogen, fluorine, chlorine, bromine, and iodine. Uh, now, now halogenoalkanes. The first thing is we're going to talk about physical properties of halogenoalkanes, and the physical properties are that they are polar compounds. They have permanent dipole interaction. So they have permanent dipole attraction or interaction. And you might be asked to draw a molecule showing that. So if you have a molecule of, let's say, chloromethane, which has Cl in it, and the carbon that is attached to Cl is going to have a partial positive. It's going to be a polar bond, and this would be partial negative. This chlorine part is going to be partial negative. And if there's another molecule which is in exactly the same situation, you have carbon and it has Cl, and this is partial positive, this is partial negative, then the negative part would attract the positive part of the other molecule. There's going to be permanent dipole attraction between molecules. So the melting and boiling points are going to be higher compared to, that's the first property. Melting and boiling points are going to be compared to alkanes and alkenes. This is the only thing that we have done compared to alkanes and alkenes. So that's about physical properties because alkanes and alkenes only had van der Waals forces, but halogenoalkanes they have permanent dipole attraction. And remember, the strength of the dipole depends on many things. It depends on electronegativity difference because not all halogenoalkanes are equally electronegative. For example, the CF bond is going to be highly polar. So the partial positive charge and the partial negative charge are going to be very, very strong. But on the other hand, a Cl bond would have relatively weaker dipoles. And if you compare it with a C and I bond, then the dipoles would be even weaker. So it all depends on which elements are electronegative, what's the difference in electronegativity. So from going down the group, you already know this. From fluorine, chlorine, bromine, and iodine, the electronegativity is going to decrease down the group. So your electronegativity decreases down the group. And that depends. So all your physical properties depend on that. They're obviously not going to conduct electricity, and they're not going to be soluble in water. Uh, or you can say this. You can also compare it with alkanes and alkenes. The solubility might be slightly higher, but not really soluble. So we're going to talk about that as well. That they are not very soluble. Or in a relative sense, slightly more soluble compared to alkanes compared to alkanes and alkenes. And why are they not soluble? Because they can't form hydrogen bonds. But since they are polar, so they might weakly attract water molecules. And then there's another point, which is that sometimes dipole would also cancel out. One example is a CCl4 molecule. It's completely non-polar. Why? Because all four bonds are Cl bonds. So all four bonds are Cl bonds, and the dipoles cancels out. So it could be, it's not always, they can also be non-polar halogenoalkanes as well. Okay, is this clear so far, Isa, Ethan, Mohammed? Is this clear?
Yes, sir.
Yes.
Yeah.
So now coming to the reactions, the first thing is how do you form them? So we left. I think we did but let's ignore that for now. How to form or formation of halogenoalkanes. Now, formation of halogenoalkanes, we've already studied a few reactions. I'm just going to mention them. The first one was, so number one was the photochemical chlorination or bromination of, or you can call it the free radical substitution. So it was alkane plus Cl2 or Br2, and plus you needed UV light, right? You had your initiation, propagation, termination steps, and you got molecules that had chlorine or bromine substituted in them. The only issue was that it was an uncontrolled reaction. You can't really figure out how many chlorines are going to get substituted and at what positions. Number two, the reaction that we studied was the addition reactions, the electrophilic addition reactions of alkenes. Of alkenes. So electrophilic addition of alkenes would lead to uh, halogens in the carbon chain, like bromination, or you could add HCl or etc. So we did all these reactions where halogens would get added to alkenes. Now the third one that we're going to talk about is number three is from alcohols. Nucleophilic substitution of alcohols. So nucleophilic substitution of alcohols, and let's talk about this in detail. Uh, the thing with this reaction is that you have an alcohol. Uh, let's call it ROH, and there's going to be a reaction, and the OH would be substituted by a Cl. A halogenoalkane is going to be formed. Now, there are a number of conditions for this reaction that can be used. So some of them, we're just going to talk about some of them because there are lots of conditions, lots of reactions that can do this. So you have PCl3, plus heat, that would give you this molecule. You could also use PCl5, but for PCl5, reaction is highly explosive or very vigorous. or you could use SOCl2 plus heat. This one gives the best yield. So these three reactions, number 1, 2, and 3. Now, to get other halogen substituted halogenoalkanes, what you could do is, for example, if I want to make RBr from it, like I don't want chlorine, I want to substitute the OH with a Br. The reaction conditions for that are bromine, red phosphorus plus bromine plus heat. Or you could also, or you could also use HBr. So they're two separate reactions. And what you can also do is you can substitute it with iodine. So for that, it would form the carbon chain with an iodine. The reaction would be red phosphorus plus I2 plus heat, or you could also use HI plus heat. Anyways, these there are a number of reactions where you could substitute the OH in an alcohol with a halogenoalkane. So just remember this: how to get a bromine, red phosphorus plus bromine, red phosphorus plus iodine gives you iodine in the molecule, and for chlorine it's PCl3 or PCl5 or SOCl2. These can be used. Okay, is this clear? Isa, is this clear? Ethan, Mohammed?
What is meant by red P?
Nee, which one? I said that's. I'll just explain quickly. I said remember, there are two types of phosphoruses. There's a. I'll just quickly draw the diagram. Phosphorus is one of the phosphorus is this one. Uh, in that each phosphorus atom is bonded to three other phosphorus atoms. You can count the bonds. Each one is bonded to three other phosphorus atoms. And then there is a polymeric form of phosphorus, which is that. This is P4. And then there is a polymeric form of phosphorus where uh, what actually happens is that you have pretty much the same molecule, P4 molecule, but these molecules they end up reacting with each other. The middle bond would break and the phosphorus atoms would start connecting with each other. So that's a polymeric form of phosphorus. So phosphorus has two structures, it's like carbon. Carbon has graphite, it has diamond, it has. So red phosphorus is one type of phosphorus. Ethan, is this clear?
Yeah. Okay.
Okay, and this one of them is a white phosphorus. Let me just show you the structure of red phosphorus because you got one. It is the polymeric form. Okay, it's this one. Uh, where this was P4. This is the polymeric form that I drew. So, anyways, coming back to this, this is not important, but you got a question on this, although it's not in your syllabus. They had asked you to draw a polymer out of this. I say, anyways, moving on to other things. Now, the reactions that most halogenoalkanes undergo, that's called nucleophilic substitution. So, what is nucleophilic substitution? The short form for nucleophilic substitution is SN. That's that's the short form. Nucleophilic. N stands for nucleophilic. S stands for substitution. Now, what happens in this reaction? Let me write the summary of all the things that can happen. That you have, as now you have a halogenoalkane. X could be chlorine, bromine, or iodine, and there are three separate reactions that could take place. The first one, You could add NaOH aqueous and reflux. That's the first one. What's going to happen is that the halogen would get substituted by an OH. So the nucleophile in this case is OH minus 1. Okay, that's the summary. There's going to be OH minus 1 from NaOH, and the OH minus 1 is going to come and it's going to just remove the halogen. Okay, let's use a halogen over here. Let's say there's Cl over here, and the Cl minus 1 would get knocked out. So it's a simple reaction. This is what's going to happen. The other thing that might happen is the second reaction is it's with NaCN or KCN ethanolic. Or you also refer to as alcoholic. Ethanolic simply means that you're not using water as a solvent, you're using ethanol as a solvent. And what happens in this case is that the nucleophile is CN with a negative charge. And CN does exactly the same. The RCl changes to RCN. And the Cl ions, they get knocked out. Okay, so there's a substitution happening. Just exactly the same as the one that happened with OH ions. And the third one is that you have NH3, which is ethanolic. Plus, you needed reflux over here as well. So the third one is NH3 could be ethanolic, and you would also need reflux. Or there could be another condition, which is that you could use NH3 gas and you can heat it in a sealed tube. So that could be another reaction, and this time your halogen would get substituted by the NH2 group, and that's what's going to be formed. And the nucleophile in this case would be NH3 with its lone pairs. So you had Cn minus 1 lone with lone pairs. So three nucleophilic substitution reactions. First one, OH comes along, substitutes the halogen. Second one, Cn minus 1 comes along, substitutes the Cl and forms this one. And the third one is NH3 substitutes and you get NH2. In this case, amines are formed. In this case, nitriles are formed. And in the first case, alcohols are formed. So you have three separate reactions, TK, and you have to memorize all the three reactions. In addition to that, what you also have to memorize is the mechanism of these reactions. So we know it's nucleophilic substitution. Uh, but what's the mechanism? So mechanism of nucleophilic, and this mechanism applies to all of the reactions that are given above. And you also have to remember that there would be two separate mechanisms for the reactions mentioned above. There's going to be an SN2 mechanism. So the question is, what is the SN2? What is the SN2 mechanism? The SN2 mechanism stands for uh, it's used for primary halogenoalkanes. Now the next question is what's a primary halogenoalkane? It's a halogenoalkane where the alpha carbon is only bonded to just one carbon chain. One carbon chain.
सर अल्फा कार्बन वो
Next
था
time.
जिसके साथ OH का बॉन्ड हो
हाँ, alpha carbon is the one जिसके साथ which has the functional group. ठीक है. So
ओके
मतलब it's क्योंकि we are talking about halogenoalkanes, so alpha carbon would be the one which has the halogen attached to it. ठीक है.
ओके सर
अच्छा, so three reactions: OH minus one, Cn minus one, NH3, substituting the Cl in the molecule. So primary halogenoalkane is one where the alpha carbon, the one that is bonded to the halogenoalkane. ठीक है. So you have carbon and you have Cl and you have H and there's only one carbon chain, right? Ethan Mohammed, is this clear? What's an alpha carbon and what's a primary halogenoalkane?
Yeah.
Yes.
ठीक है. So it's basically you're looking at a carbon atom with two hydrogens, and we're only interested in the carbon atom that's bonded to the functional group, not the rest of the carbon chain. ठीक है. We don't care about that, about those carbons. Now the mechanism for this reaction. What happens? What's a nucleophile? So let's say you have this molecule. You have a molecule of R, C, and there's Cl, and you have H, and you have H. Now it's a highly polar molecule. Its carbon is partial positive, Cl is partial negative. So there is polarity, and at the same time you have a nucleophile that you've introduced into the system. You have an OH minus one. Now you have an OH minus one nucleophile. Now the middle carbon is partial positive. ठीक है? You already know why it's partial positive because uh, because Cl is highly electronegative. So what's a nucleophile? The nucleophile and the other nucleophiles that we have are Cn minus one, and you have NH3. ठीक है? The ones that we talked about above. They're all going to have the same reaction. A nucleophile is anything that is attracted to positive charge. So the OH minus one would be attracted very strongly to this carbon which is positive. That is by definition water. Uh, so that is by definition what nucleophile is. And if the OH minus one gets attracted to this carbon positive, the electrons over here in this bond, they're going to break and they're going to get repelled. Okay, so Cl wants to pull electrons. OH minus one is, with its negative charge, is pushing the electrons away, further away. In the next step, what happens is a transition state is forming. What's happening is you have R and you have carbon and you have hydrogen and hydrogen. Now what's happening is slowly the Cl is drifting away and slowly the OH is coming closer together. So there's going to be this brief temporary, for a very minor instant, there's going to be this transition state that would be form and that would be existing. Okay, so is this part clear? Mohammed, Aiza, Ethan?
Yes.
जी
Okay. And this entire thing would be negatively charged. Why? Because the OH that was coming in had a negative charge. So the OH is coming in and the Cl is
I have
breaking off. Yes.
I have a question. Why is the chlorine drifting apart again?
Because the OH is attacking the positive carbon, right? over here.
Yeah.
So if the OH brings along, I mean, it's bringing negative charge, right? So if it moves
Yeah.
closer and closer, the electrons over here are going to get repelled. Is that clear?
Oh, all right. Yeah.
So that's the reason why the Cl is drifting away. And in the next part, the Cl eventually breaks off. So that's your final move that's happening. So your molecule now is going to look like this. It's going to look exactly the same, except it's going to look exactly the same, except that the Cl is now gone, and OH has taken its place. So the Cl minus one has broken off. So that's your final step. I said, remember, this is just a transition state. It's a transition state, and in which carbon is partially bonded to 5 atoms. And one other thing that you have to remember is that this entire thing is a one-step reaction. Although you see 2 steps, but this is basically just one step happening. That the OH is coming towards this carbon positive and the Cl is breaking off. That's pretty much it. That's the whole reaction. Is this clear? You have to get every curly arrow, everything should be right when you're drawing this. Is this clear? Ethan, clear?
So what's
Yes.
the difference between a transition state and an intermediate?
A transition state doesn't actually, it doesn't really form. Like it's highly unstable. It's highly unstable, and you can't stop the reaction here. It's either this or this. This thing is just a hypothetical transition state. You might observe it for a very minute second, but this doesn't really actually form in the reaction. You can't stop the reaction here. Is this clear? Do you get the point?
Yes.
Now compare that to an compare that to an
Uh,
Mhm. Any questions?
uh, can I ask why the nucleophile attacks in that direction? Can it attack in other directions as
No,
well?
that's also very important that it's always going to attack from this side because there's negative charge over here. So it never attacks from the direction of the chlorine. Is that clear? So
Oh, all right.
it's either from this side or from this side. I said, anyways, but the direction is not that important because the shape of this molecule is not the actual shape of the molecule. Ethan, is that clear?
Mm, yeah.
I mean, the molecule doesn't actually. It's a tetrahedral molecule. It doesn't look like this. Uh, so the only thing that you have to get right is that the OH minus one should always come from the opposite side.
All right. Yeah.
I said, and so that's a one-step reaction. You have to be very careful. It's a one-step reaction. Transition states are not actually obtainable. They're not actually formed. It's just one molecule transitioning into another molecule. And if somebody tells you to identify the energy profile diagram for such a reaction, then it's going to look like this. That it's, I mean, whether it's exothermic or endothermic, that's irrelevant. It's going to be one-step reaction. So you have reactants and you have products, and this over here is in the middle somewhere. This is your transition state. So that's where the transition state is. So remember, this is for primary halogenoalkanes. We can now have a discussion for tertiary halogenoalkanes. and that's known as SN1. So tertiary halogenoalkanes mechanism. So what's the mechanism in this particular case? If you have a tertiary halogenoalkane, the first thing is, what is a tertiary halogenoalkane? So it's a halogen where the alpha carbon, the one that is attached to Cl or any other halogen, is surrounded by carbon chains on all sides. So that's what a tertiary halogenoalkane is. One way to identify that is that the carbon, alpha carbon, would not be having any hydrogen atoms attached to it. So the mechanism for this reaction is going to be like this: that in the first step, so in the first step you have the OH ions are not going to play any role. The CCl bond would break on its own. And that would result in the formation of a carbocation where you would have R, and this will have a positive charge, and the Cl minus 1 has broken off. And in the next step, the OH minus 1 or any other nucleophile, Cn minus 1 or NH3, which was also our nucleophile, the OH minus 1 with its extra electrons is going to move in, and it's going to quickly bond with the carbocation. And you get your final product in this way. So it's going to be R, and there's going to be OH attached to the carbon atom. Now this is a proper two-step reaction. We have a slow step, and you also have a fast step. And this in the middle is your carbocation intermediate. So you have a carbocation intermediate in the middle. So remember, we haven't discussed the reason why, but what we have discussed so far is that for tertiary halogenoalkanes, the Cl breaks off first, and the OH minus 1 comes in much later. One of the reasons for that is uh, that the OH minus 1 would not be able to attack the carbon because it's surrounded by large groups. On all sides, there are these large carbon chains, so the OH minus 1 does not find a direct route to attack the carbon atom. Previously, it was easy. That the alpha carbon was very exposed because it was surrounded by hydrogen. Hydrogens only have one proton; they're non-existent, almost non-existent. So the OH minus one was capable of attacking the carbon atom, but now the OH minus one is not capable of attacking the carbon atom because it's surrounded by large groups. So the first step is slow because you would have to wait a very long time for the Cl to break away. And you're just hoping that you heat the mixture so that collisions happen, and when collisions happen, the Cl breaks off. And as soon as the Cl breaks off, you've added a lot of OH ions. The OH ions quickly attack the positive carbocation and they bond with it. Okay, Aiza, Mohammed, Ethan, is this clear?
Yes.
Yep.
Yeah.
Just so remember, it's a two-step reaction. Ethan, do you have any questions? So it's a proper two-step reaction. Yeah.
I was wondering about secondary halogenoalkanes.
I'm going to talk about them. And I'm also
which mechanism?
I'm going to talk about them. Okay, so first this one. You start off with reactants. You have a carbocation intermediate. Which is actually formed in the reaction, and then you have your products. So it's a proper two-step reaction that's going on. Now, this about the secondary halogenoalkanes. First thing is it's going to be a mixture of SN1 and SN2. But more importantly, what we need to discuss is why is this SN1? Why is the mechanism so different compared to SN2 reaction mechanism? So we're going to talk about that in a lot more detail, and also remember that secondary halogenoalkanes, they have a mix mechanism, and we're going to talk about that in detail as well, probably in the next class now. Okay, but so far is this clear? I mean, these mechanisms, we didn't do the understanding part yet. I mean, we did some of it. I mean, this is obviously clear, but we have to do this in detail. That why is SN2 happening for tertiary, for primary, and why is SN1 happening for tertiary? Okay, so let's continue in the next class then for this. Okay, any questions? Ethan,
For the SN2, is there any conditions?
I mean, there were conditions like these. These were the conditions. I gave you the conditions. Like the nucleophile could be OH, it could be CN-1. Let me highlight that. It could be any one of those. So you have an OH-1 nucleophile, a CN-1 nucleophile, or you have an NH3.
So for each.
For each, there are different conditions. Like for the first one, it's NaOH aqueous and reflux. For the second one, it's KCN or NaCN. NaCN. This should be NaCN. 1 second. And that's ethanolic. And for the third one, it could be NH3 ethanolic or reflux, or it could be NH3 gas, and you heat it in a sealed tube. Okay. So let's continue with this tomorrow then. Okay, then take care.
Yeah, sir.
Yes.
सर मेरा क्वेश्चन लाइक पढ़ाई से रिलेटेड नहीं एग्जाम्पशन के रिलेटेड है जो प्रैक्टिकल एग्जाम्पशंस हो रही हैं सर वो उनमें 0% लग रहा है ना मतलब आपको 50% भी नहीं मिल रहा ना
ये मुझे नहीं पता क्लियर लेकिन ऑब्वियसली अगर वो नहीं है तो ऑब्वियसली वो टोटली एक्सक्लूड ही होगा ना
सही
मतलब 0% का क्या मतलब है कि 0 आउट ऑफ वो दे देंगे 0 आउट ऑफ 30
मतलब डिवाइड हो जाएगी वेटेज पेपर 1 और पेपर 2 की आपके गलती के चांसेस
तो पेपर 1 पेपर 2 होगा ना
हाँ जी
तो वो बस वही होगा वही वेटेज होगी वो टोटली एक्सक्लूड हो जाएगा ठीक है
तो सर उससे फिर जो ग्रेड्स हैं वो नीचे जाएंगे मतलब गिरेंगे
नहीं उससे कोई फर्क तो नहीं पड़ना चाहिए वो तो
अच्छा
मोस्ट लाइकली अच्छे होंगे ठीक है
मतलब एग्जाम्पशन ले लेनी चाहिए
हाँ चॉइस
ऑप्शन दी हुई है ना
अच्छा ऑप्शन दी हुई है हाँ मैं थोड़ा I'll search
लो
on
या
that
ना लो
नहीं मैं थोड़ा सा I'll search on that ठीक है
सही है सर
चल ठीक है ओके देन टेक केयर
ओके
Yeah.
Thank you.